Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Ashir Zaman Khan from Government Muslim Science College, Hyderabad. So we have today's topic, that is derivative of the product of two functions or product rule of two functions. So we can see that the derivative of product or product rule. So if we have the two functions, that is f of x and g of x, we can find out the derivative of that product. And this is the statement like f of x, g of x, the derivative dash means the derivative of f of x into g of x is equal to g of x will be the same, the derivative of f of x. And in the same sense, f of x will be the same, the derivative of g of x. And guys, I just want to remind you that if you watch the complete video, you can understand better. So watch it completely. Otherwise, you can not understand the whole idea. So we can write it in this form also. F g dash of x is equal to f dash g same g dash f same. So we will going to prove this formula product for rule by using first principle method. So guys, we have done earlier the first principle method, that is f dash of a is equal to limit x approaches to a, f of x minus f of a divided by x minus a. So we are just going to prove this formula by putting f of x as f of x into g of x and f of a as f of a into g of a. So we are just putting up in this way, just plug in the values in the formula. Now just plug in the value f of as f of x is equal to f of x into g of x over here, minus f of a will be replaced by f of a into g of a divided by x minus a in the first principle method. Now what we are going to do, just add and subtract g of x into f of a on the right hand side of the above equations. So what will happen in the next step, we can see further. So after the addition of g of x and f of a, what will happen, we have f g dash of x is equal to limit x approaches to a, f of x into g of x minus f of a into g of a, the same thing. We subtract f of g of x into f of a and then add g of x into f of a divided by x minus a. Now we can these are the four values and we can make two pairs. How can we do this? We are just having first value, that is f of x into g of x, and the value, that is third value, g of x into f of a. So we have taken into in a bracket over here, and now the fourth value, that is g of x into f of a, and the third value, that is f of a, second value f of a into g of a, we have separated together in a bracket divided by x minus a. Over here, if we see here, it is interesting to see that the g of x is the same in the both of these two terms. It is common throughout, so we have taken out common from this bracket. So the remaining thing is, that is f of x minus g of f of a. Over here, this is also interesting to see over here, that is f of a is common throughout. We have taken out f of a as common. G of x minus g of a will be remain in the bracket, and as usual the whole numerator will be divided by x minus a over here, this one. After that, we can do something. Now if we split the limits and LCM on the right hand side, what will happen in the next step? We can see that in the next. Now by splitting the limits and the LCM of the function, the present shape is that f g dash of x is equal to limit x approaches to a. We have taken out g of x as common, f of x minus f of a divided by x minus a, and then again limit plus limit x approaches to a, f of a is common, g of x minus g of a divided by x minus a. And if we look these two forms, f of x minus f of a divided by x minus a, this is first principle of f of x. And this is also, if we see this form g of x minus g of a divided by x minus a, this is first principle derivative of the g of x. So by applying limit, putting x equal to a, so what will happen? F g dash of x is equal to g of a is the same f dash of a. F dash of a means the derivative of the function f of x at a, and plus f of a will be the same, the g dash of a, that is the derivative of g of x at point a. So it is the derivative at the specific point a of the function, which is in the product f of x into g of x. We can write in we can find out at the general point also. How can we do this? And fg dash of x, instead of a we are putting over here x, so g of x same f dash of x plus f of x same the g dash of x, means g of x same the derivative of f of x and f of x same the derivative of g of x is the derivative of the product function at the general point x. We can write in many ways. So how can we write it in other way? We can see over here fg dash is equal to g same f dash plus f same the g dash, and also let u is equal to f of x and v equal to g of x. What will happen? The u dash means derivative of u with respect to x, or f dash of x, we can write it in this way, and v dash is equal to the derivative of v with respect to x, or g dash of x. So we can write it in another form, that the derivative of u into v is equal to v same the derivative of u with respect to x and u same the derivative of v with respect to x. We can write it another form. How? Let's see. So we can write it in this form also, that is u into v whole dash means the derivative. So u dash means the derivative of u with respect to x, v same the v dash the derivative of v with respect to x, and u same. So don't forget that this is used rapidly. This will use in rapidly in the derivative of the functions like which are in the product form. So we can use in the exercise also. And this is the end of our lecture, and we will meet in the next lecture. Till then, Allah Hafiz.